So we start working with functions and we start storing data in our blockchain by appending a new value and also referring to the old value. Now, right now we're always referring to the first value though, which always is a 1 because that is what we start with. If we want to get the last value of the blockchain list, we actually can use -1 though. That's a convenient trick, though trick sounds like it's some workaround. It's actually a built-in functionality which simply accesses the blockchain from the right. So 0 is the first element from the left, but -1 is the last element because we start accessing it from the right. And why not -0? Because there exists no such thing as a -0. So -1, we could also use -2 to use the second last element, but -1 will actually now give us the last one. If we save that and I run that code again, you see now what we have is we got our blockchain here in the last line where we have 1 and the new array with 1 and 5 free. And then we're nesting this further and further, as you can see, because we're always referring to the last element of our blockchain, and the last element will always be a nested list. Now, actually, for that reason, we should also wrap that starting 1 with another pair of squared brackets so that this is a nested list too. Now, with that, if I clear this to make it easier to read, here we see how we now execute our code. We always add an additional level of nesting because if we access the last element in the second addValue call, we get this result because here the last element actually is this list. So when we append a new value to our blockchain, we take the old blockchain, which is this part, and then we append the old last value, so this one, we append it as the first element in that new array we're adding. Remember, we're adding an array here with square brackets. This is what we append. And then this new array or this new list actually also has this value here at the end. And for the last addValue call, this is the part we're starting with. And then we're appending a new list, hence the outer squared brackets here. And in that new list, we have 5.3 as a new value, this value. But then we access the last value of the old blockchain, which is this value here. And this is why you now see this value with 3 opening and 1 closing square bracket in here. So this is the same value as this up here. And that simply is added because it's the last value of the old blockchain. So this is the logic we have right now. Each new block we add contains the old data as well as the new data. The problem we of course is the new data always is the same. It never differs. It's always 5.3. So it would be nice if we could actually manipulate that and tell the function here to use different values.